We're going to solve by completing the square. Completing the square is a little bit difficult at times because very specific things need to happen. To start here, in order for me to complete the square, this x squared term has to have a coefficient of 1. So in this scenario, when it doesn't have a coefficient of 1, we need to get a coefficient of 1, and then we start to maneuver some things around. So that's my first goal here, is getting a coefficient of 1. And in order to do that, that means I have to divide everything by 4. And you could do some other things first, but I'm just going to start there. And you can move over that 4x with it if you want first, but it really doesn't matter. I'm just going to get rid of that division, that 4 from the start. That's going to leave me with x squared minus a half equals x. Then, after that, you can now start to get everything in position here. So I'm going to subtract x. I don't have any like terms on that side. So I'm going to have x squared minus x minus a half equals 0. Then from here, in order to complete the square, I want to get rid of this minus a half because I want to focus on these terms right here in order to complete the square, because the way it is right now, it's not in a form where I could factor it. So I want to create a form that I could factor. So therefore, I want to complete the square. So I'm going to use the method of completing the square, and I need to get rid of this half then. That's going to leave me with x squared minus x equals a half. So what's useful about the completing the square method was what our whole goal is we're going to be left with something like this. Like it's going to be x minus, let's just say 2, for example. So it's x minus 2 squared. So that's going to symbolize that we're doing x minus 2 times x minus 2. Like that's the whole goal here, is to get a term where it's just the same thing being multiplied twice. So we have to do some manipulation here in order to have that happen. And in its original form, like where x squared minus x minus a half, I couldn't really do that. So let's go ahead and do this. I'm going to complete the square. Let me erase this so it doesn't confuse anybody. So completing the square. This is my a term. This is my b term. I want to take b divided by 2 and square it. So my b is negative 1. This is the coefficient right here, negative 1 over 2 squared. Negative 1 over 2 squared is going to be positive 1/4. I get positive 1/4, which means now that I'm going to add on a 4th on both sides because I want to offset that 4th. I'm adding on a 4th. Adding it to the other side will just balance it and keep it even, keep it like okay, like I'm just changing the visual essentially. Like I'm not actually changing anything about the problem. I'm just changing the visual. So I have now this scenario where I have a perfect square. Now, next step is going to be writing it from this form to that form I had earlier, like x minus 2 squared, writing it into a x minus something squared. So in this case, it's going to be x minus 1/2, because 1/2 times 1/2 is 1/4. And what you always want to just notice here, whenever you're going from this step to this step, this x term is coming from here, minus because of the sign here, and then the 1/4 because 1/2 times 1/2. But if you just look here, the term before you square it, so that term before when you divide by 2, and then right before you square it, that's going to be the term that goes here. It's a little bit of a shortcut if you don't want to, if you want to check your work and make sure you're doing this accurately. That's going to happen where the term right here is going to be this term right there. So just something to keep in mind as you go through completing the square. I usually tell that as a little bit of a cheat, maybe, if you want to think of it that way. And then squared. And then the other side, since we had that 1/2 plus 1/4, we want to go ahead and add that. So I'm going to do that off to the side here. Find the least common denominator of 4. So that's going to become a 4. This is going to become a 2 because I'm multiplying by 2. So I will get, let me erase that. I'll get 2 over 4 plus 1 over 4. 2 plus 1 is 3 over 4. So this side I'm going to have 3 over 4. I'm going to rewrite this just to clean it up a little bit because I know I was talking and explaining things, so I was just writing some crazy arrows and everything. So let me just clean this up a little bit. Now from here, we want to solve for x. So this is now solving for x. So I'm going to take the square root of both sides because I have it squared. If I have x squared equal to 4, in order to solve for x, I take the square root. So in this scenario, I'm going to have x minus a half equals, now here's something people forget. Since it's squared and we're taking the square root, we have to account for both the positive and the minus square root of 3 over 4. Now, I'm not done with the square root of 3 over 4. I could do more things there, but I'm just talking about this just step by step. I have to take the positive and the negative. Just like here, if I was to solve this, this would be x equals positive negative square root of 4 is 2. So I get positive 2 and negative 2. Because the whole reasoning behind that is because 2 squared is 4 and negative 2 squared is 4. So that's why we have to account for both the positive and the negative here. So in this scenario where I'm taking the square root, I have to account for both the positive and negative 3 over 4. So continuing with the 3/4, I have x minus a half equals positive negative. Since I have a fraction with a radical, I can take the square root of the top over the square root of the bottom. That's going to give me, let me just keep going underneath. I don't like going off to the side. That's going to give me x minus a half equals positive negative square root of 3, because I can't take the square root of 3, over 2. And let me not put the fraction bar over everything like that. Over 2, because the square root of 4 is 2. So the square root of 3 over 4 is the square root of 3 divided by 2. And I still have that plus minus. And finally, we're starting to crawl down to the end here. I just have to get x by itself, and I'm going to add 1/2 over to both sides. So I will get x equals positive and negative square root of 3 over 2 plus a half. Sometimes it might be beneficial to break it off into 2, so you'd have like positive square root of 3 over 2. I guess you don't need the plus sign. Positive square root of 3 over 2 plus a half, and then the negative square root of 3 over 2 plus a half. In some cases, that's going to be helpful. In some cases, you're just really just moving in place. Like, it really doesn't do anything for us. But here, I do want to just add on an extra step here. Since I have the same denominators in 2, I'm going to rewrite this as x equals positive and negative square root of 3 plus 1 all over 2. Because I have the same denominator, so I could put the whole thing over 2, just positive negative 3 plus 1 over 2. So here I would have square root of 3 plus 1 all over 2. And then here I'd have the negative square root of 3 plus 1 all over 2, like that. I wouldn't require 2 separate writings of this answer. If we didn't have the square root of 3, like if it was actually a whole number where we could actually add things together, then we would want to go down further. But here is perfectly acceptable, at least for me. And I think most teachers or most textbooks would write it like that. Yeah, completing the square, difficult process at first, like definitely something like this on this problem. The trick here is making sure that you are getting this coefficient of 1 here, and then you got to do a lot of manipulation. You got to move a lot of things around. You have to get it into this form here where I got x squared minus the x minus the 1/2, but I moved that 1/2 over. So then we're focusing on these terms here after we get rid of that 1/2. So there's the answer down there. Thanks for watching. Good problem.